Okay, so this is part 2 of the lesson 5. So now we'll be discussing about repetition control structures. Repetition control structures are Java statements that allows us to execute specific blocks of code a number of times. So that's why it's called a loop. Okay, so we can execute statements, blocks of code for several times. So there are 3 types of loops in Java. We have the while loop, we have the do while loop, and we have the for loop. And this will be discussed in detail as we go on with our video lecture. So the while loop. The while loop is a statement or block of statements that is repeated as long as some condition is satisfied. So the condition should be true, then it will do the statement inside. So this is the form or the syntax. So while, then we have here inside parentheses, we have the Boolean expression. So if this is true, it will execute statement 1, statement 2, and so on and so forth until the end of the block. Of course, we can remove this if we have only one statement, but it is better if we use always the curly braces. That will make your program more readable. The statements inside the while loop are executed as long as the Boolean expression evaluates to true. So that is the while loop. And sometimes it's called the pre-test loop because the testing of the condition or the expression is before we execute the loop. So here is an example. Integer x equals 0. So while x is lesser than 10, so that is 0, so this is true. Then it will print the value of x. Then after printing the value of x, it will add 1 to x. So that is true until the time that x reaches the value of 10. It becomes false because 10 is no longer lesser than 10 and execute. So this will print the numbers 0 to 9. So let's try that. Let's open our online Java compiler. Sorry. So the GDB online. So let's choose Java. So I'll remove this one. Delete. Okay, so let's copy the code. So if we run the program, so this displays the numbers 0 to 9. And if we're going to count the number of times the block of code is executed, it is 10 times. So 0, it's true, 1, 2, 3 until it's 9. Then it adds 1, x becomes 10. 10 is no longer lesser than 10. So the condition here becomes false. It exits from the loop. That's why it will print only from 0 to 9. So here's another example, but we will not be doing this because while true, system that out the print line hello. So this is an infinite loop because this one will never become false. So you have to manually stop the program. Example 3. For this one, this is a no loop because the condition here is already false. So it will not print hello because it will not go inside the loop if this is false. Then we have the do while loop. The do while loop is similar to the while loop. The statements inside the do while loop are executed several times as long as the condition is satisfied. So the condition should also be true. The main difference between the while loop and the do while loop is the statements inside the do while loop are executed at least once. So the do while loop has the form do, then we have the block of statements or code, and then while the Boolean expression. So here you notice that we first execute the program before we test for the condition. So this is actually a post-test loop. That is why the code here will be executed at least once. Unlike in the previous one, it is possible that the code inside will not be executed at all. Okay, so here's an example similar to the previous one. Integer x equals 0, do, then system out, the print line x plus plus, so while x is lesser than 10. So this is the same, it will also produce the same output as the previous one. Wait. Place a semicolon here. So there it is. Produces the numbers 0 to 9, just like what we have done a while ago. But this one is using a post-test loop. So example 2, this is an infinite loop because the condition here will never become false. And this one, the condition is false at once, but again, it will first execute this before it will pass to the condition. So it will execute print hello for this example. So coding guidelines. Here are common programming mistakes when using the do-while loop. That is forgetting to write the semicolon after the while expression. So we should have here a semicolon. So just like in while loops, make sure that your do-while loops will terminate at some point, or else we're going to have an infinite loop. So the next one, we have the for loop. So the for loop allows execution of the same code a number of times. So the loop has a form for, then we have the initialization expression, semicolon, followed by the loop condition, semicolon, and then the step expression. Then inside the block, we have the block code here. So where initialization expression is the initialize the loop variable. So you can, let's say for example, let's take a look at the previous one. So in this example, x here is our loop variable. And you notice here we initialize our loop variable to 0. So you can do the same thing with the for loop. So in this place, you place here the initialization. Then the loop condition compares the loop variable to some limit value. So if we're going to look again at our previous example, this is our loop condition. Okay, and then we have the step expression updates the loop variable. So that is how we place that here, the loop condition here. So initialization, loop condition, then step expression. Example of step expression. Let's take a look at our previous example. This is an example of step expression. So actually we have these 3 parts in just a single line of code. That's for a for loop. So example here. So we declared I for I equals 0. That's our initialization. I is lesser than 10. That's our condition I plus plus. Then system that out that print line I. So let's try that. So I'm going to copy this code, paste it in our online compiler. I think we're missing one. Okay, so beautify. Then we run the program. So that's 0 to 9. So what if I change this one to 20? If I run the program, so this time around it will be from 0 to 19, or it looped 20 times actually, from 0 to 20. Okay, so that is our for loop. So the code shown above is equivalent to the following while condition. So again, I have shown you this a while ago, that this is our initialization, this is our condition, place here, and then this is our code inside the loop, and I++ is our step expression. So that's our loop. We'll be having more examples later in our later videos. So we have now branching statements. Branching statements allows us to redirect the flow of program execution. So we have the break, continue, and return. So unlabeled break statement terminates the closing switch statement, and flow of control transfers to the statement immediately following the switch. This can also be used to terminate a for, while, or a do while loop. So we can use the break to close a switch, terminate a switch, or terminate a for, while, or a do while loop. For example, so we have for names, for example, and then string search name is a boolean, found name false, for integer equals 0, names length, so that's the length of the array here. But anyway, I'll just be showing you this. So if, what will this do is, if the name is equal to, the name inside the array is equal to Isa, the name we're searching, if they are equal, then found name equals true, then break. That means even if the loop is not yet finished, it will go outside the loop. So because there's no need to continue if you already have found the name inside. So that's the use of the break. It terminates the loop. Now, label break statement terminates an outer statement which is identified by the label specified in the break statement. The flow of control transfers to the statement immediately following the labeled terminated statement, or the labeled statement. The sample program in the next slide searches for the value in a two-dimensional array. Two nested for loops traverse the array. When the value is found, a labeled break terminates the statement labeled search, which is the outer for loop. So here we have here search label. This is our label. And then we have here, so the search label is outside the outer for loop. So we have two for loops here because we're searching actually a two-dimensional array. Now, once we found the number, we break search label, because if this is just break, it will just go outside this inner loop. But placing a label here means we're going outside the outer loop. So that's the purpose of placing a label in our break statement. Then next we have the unlabeled continue statement. The unlabeled continue statement skips to the end of the innermost loop body and evaluates the Boolean expression that controls the loop, basically skipping the remainder of this iteration of the loop. So if we have an iteration, if we have continue, it will ignore the next block of code, but it will go back to the condition, the loop condition. So example here, we have names here. So if name is not equal to, so we have here the not equal to Bea, continue. That means it will go back to the loop condition, or the loop. It will go back to this code. So since it went back to this code, it will not pass through count, because this one is counting only how many Beas are there inside this array. Okay, so if it is not equal to Bea, proceed to the beginning of the loop. That's the purpose of continue. So it will not pass through this, so it will not count. It will only count if this is false. So that's the line of code. The labeled continue statement. The labeled continue statement skips the current iteration of an outer loop marked with the given label. So we have here two. So just like in the labeled break, we have here two loops. But we want that if this is equal, we go back to the outer loop. That's why we place here a label for the outer loop, and then we type continue outer loop. So instead of going outside this loop, it goes outside of the outer loop. Then we have the return statement. Return statement is used to exit from the current method. Flow will control returns to the statement that follows the original method call. So to return a value, we also use the return statement. Simply put the value or an expression that calculates the value after the return keyword. So we'll be doing this often. For example, return ++ count or return hello. So the data type of the value returned by return must match the type of the method's declared return value. So we'll be learning more of this. So when a return is declared void, use the form of return that doesn't return a value. So that's void, that means it's not null. So just type return. We'll cover more of the return statements later when we discuss about methods. So summary for this lesson 5, decision control statements, we have the if else. So if we only have execute a statement or block of statements if it is true. If else, we execute some block of statement if it is true and another block of statement if it is false. If else if we have several conditions. The switch is also for several conditions but equality conditions. And then we have 3 repeat control structures. We have the while loop, which is a pre-test loop, the do-while loop, which is a post-test loop, and the for loop, which is the preferred loop, especially for loops with fixed number of iterations. And then we have the branching statements, the break, the continue, and return. So thank you very much for viewing this video.